Next report will continue Kanopus V spacecraft theme. Will be made by Elena Kravtsova from Innoter, Russia. She will speak about DPS PHOTOMOD practical application for the Kanopus V Space vehicle camera records processing.
Hello, at the previous conference I made a presentation on Kanopus-based image creation and approximate accuracy. This year the satellite has been launched together with its Belarusian twin satellite. So what I'm going to show you today are some early images captured by the satellite and the processing that went into them. So, early images from Athens, CCD camera, and a synthesized image. These images allow to interpret planes at the airfield. This is Dubai, the artificial island, a 10 by 10 kilometer image, and the image of one frame. This is Dubai International Airport Al Maktoum, MSS image, and the lower the image from PSS and the synthesized image. Also, we can clearly interpret airplanes. I'm not sure if they're visible from here, but at the bottom you can see aircraft Il-96, domestic Russian aircraft. This is a fragment of synthesized image from PSS and MSS cameras. Vladivostok and Ruski Island, also made with PSS camera and the enlarged image. This is California. Also synthesized image and the enlarged image. Now this is the imagery collected by a Belarusian satellite. This is, I guess, pipeline is in Kazakhstan. This is Khalifa bin Salman Port in Bahrain from PSS camera and a synthesized image. Floating island of Bahrain. Again, 3 pictures, MSS, PSS, and combined synthesized image. The International Airport of Bahrain, another enlarged image. In spite of good, although not record-setting, spatial resolution of these satellites, the new satellites are essentially new to domestic sector by virtue of having a variety of distinctive features vis-a-vis the predecessors. The orbital composition of the cluster and the use of solar synchronous orbit that allows to ensure guaranteed productivity. These satellites are demand-driven and they allow solving secondary tasks as well. Use of standard spectral bands and a possibility to obtain them to address a variety of economic tasks. And the optical system of satellites for the first time in Russia will have a mathematical model in RPC polynomials, which will make it easier to handle this data. As you know, it was mentioned previously, the Panchromatic camera uses 6 frames. MSS camera uses 4-frame approach. The matrix size is the same, and there is the overlap between matrices. We used the Dubai International Airport imagery for processing 4 frames with overlaps. So we've done some preliminary work related to accuracy. So the objective was to verify accuracy, but again, this is very rough, very preliminary. We created a project. Ground control points were borrowed from national maps, 40 GCPs, 10 points for each matrix. External orientation was carried out based on GCPs and tie points and checked against checkpoints. We had 9 checkpoints. We can see divergence for GCPs for external orientation. As the terrain was rather flat, the gradient was just not more than 30 meters, we could use CRTM. In the Mosaic module, we built orthophotoplan, and we verified its accuracy vis-a-vis ground control points and along seam lines. Again, you can see the accuracy. After that, we selected a few more points that were not involved anywhere, and we ran another test. We built an orthophotoplan. In position, we produced the following divergence for these points. What conclusions and findings can be made? Of course, we made a few, but again, these are very preliminary conclusions. The data is not sufficient. We still have to capture more images from different terrains. So at this stage, all we can say is we can recommend Kanopus for mapping purposes for the scale 1 to 25,000 and less. Thank you for your attention. Your questions, please. I wanted to thank you for this interesting presentation. My only question is, you provided the results in figures, but what units were used to show errors? Meters, in meters. Maybe you couldn't quite see it. All right, thanks.